Welcome to ThinkViL educational videos. In this video, we will learn about Vernier caliper, covering their theory, key concepts, important formulas, and practice questions. Now, what is Vernier caliper? A Vernier caliper is a measuring tool used to measure the length, width, depth, or diameter of small objects very accurately. Vernier caliper ThinkViL simulation is based on the concept of Vernier caliper. Now, we will discuss the parts of a Vernier caliper. Here, this is a Vernier caliper. This is the outside jaws, which are used to measure the external dimensions of objects. This is the inside jaws, which are used to measure the internal dimensions of objects. This is the measuring depth probe, which is used to measure the depth of objects. This is the main scale. This is the Vernier scale. This is the retainer, which is used to lock the movable part of the Vernier caliper. Now, we will discuss the formulas used to calculate the correct dimension of an object. The measurement, dimension, is calculated using the following formula. Measurement is equal to MSR plus VSR times LC, where MSR is the main scale reading, which is the value on the main scale just before the 0 mark of the Vernier scale. VSR is the Vernier scale reading, which is the number of the Vernier division that exactly aligns with a division on the main scale. LC is the least count of the Vernier caliper. The least count is the smallest measurement that a Vernier caliper can read. We can calculate the least count of a Vernier caliper using the following formula. Least count, LC, is equal to 1 MSD minus 1 VSD, where MSD stands for main scale division, which is the smallest value on the main scale, and VSD stands for Vernier scale division, which is the smallest value on the Vernier scale. Let's understand this with the help of the Vernier caliper ThinkViL simulation. Now, open the simulation. You will see this layout. Here, this is Vernier caliper. Remember, here main scale readings are in centimeter. Now, let's take a random dimension of a circular object. From the Show button, we can see the correct dimension of the object, which is 2.14 cm. Let's calculate the dimension using the formulas. Here, main scale reading is the value on the main scale just before the 0 mark of the Vernier scale, which is 2.1 cm in this case. Here, Vernier scale reading is the number of the Vernier division that exactly aligns with the main scale division. Now, we calculate least count by using this formula. Here, main scale division is the smallest value on the main scale, which is 0.1 cm. Here, 10 Vernier scale division is equal to 0.9 cm of the main scale. So, we got the Vernier scale division as 0.09 cm. After calculation, we got the least count as 0.01 cm for this Vernier scale. By substituting all the values into the formula, we obtain the same result as displayed in the simulation. Thanks for watching the video. For access more educational resources, visit www.thinkvil.com. And don't forget to like, subscribe, share, and press the bell icon for more updates.